Okay, so here we have an eye model, and here we have three converging lenses which we are going to use as an eye model lens. And here we have one converging lens and a diverging lens. And I'm going to show you how these two types of lenses, converging and diverging lenses, can be used to correct vision problem. So these three lenses represent, as I will show you in a minute, so these three converging lenses which represent the eye lens as a model, and when we place each one of these lenses here, and when we shine a parallel rays of light, you'll see where that parallel rays of light are going to converge. So for a normal eye, you know, these parallel rays of light should converge on the retina so that the optic nerve can detect and send the signal to the brain, and you would be able to see that. So these three converging lenses would show you one is a normal and the other two are an eye with vision defect. Okay, so I will show you one by one. Okay, so what we see here is the converging lens one, and that represents a normal eye with no vision defect. And as you can see, these parallel rays converge exactly on the retina here. So I'm going to show you this in a dark room. So this is what it looks like when the eye accommodates the lens and able to form the image of this object right on the retina. That's a normal eye. So you can see that these rays are focused on the retina. Okay, now I put the second converging lens, that's lens 2, and you can see that these parallel rays of light, after it crosses this eye model lens, it converges before it reaches to the retina. So you can see that if the rays won't converge on the retina, then this eye wouldn't be able to see. So just pay attention where these rays converge for this defective eye. So this eye has some vision defect, and we will see how we can correct this. In other words, how we can move these converging rays before the retina onto the retina right there. So I'm going to show you this in a dark room first. Okay, this is what you see in a dark room for converging lens 2, which is the defective eye. So you can see that here is the retina right here, but the rays focused in here, so it means that's where the image is going to be formed. So this eye won't be able to see this object because the rays doesn't converge on the retina. So how can we correct that? Okay, so next what I'm going to show you is how can we move this point into the retina. It's converging before the retina, so we want to move it to the retina. Should I use a diverging lens or should I use a converging lens? So let's check both. So if I use the converging lens, what happens? So if this is used to correct this vision problem, so you can see that it even moved it further away from the retina. So that's not the right lens to correct it. So let's use a diverging lens. So this is a diverging lens. If it has the right focal length, then it should be able to move this focal point to the retina. So let's put that. And you can see that this diverging lens pushed the point of convergence onto the retina. Let me show you this in a dark room. Okay, so this is what you see with the corrective lens. As you can see, these rays now are converging exactly on the retina. So we correct this vision defect by using a diverging lens. So watch without the diverging lens, or if I remove the diverging lens, that's going to be the focal point. But if I put this diverging lens in front of this eye, it will be corrected and the image is formed on the retina. Okay, the last one that I'm going to show you is the one with a vision defect, a model eye lens. So this is the converging lens number 3. So just watch what happens when I put this lens here as a model eye lens, and you can obviously see that this lens converges these parallel rays beyond the retina over there. So let me show you this in a dark room. So this is what you see in a dark room for the converging lens number 3, which models the eye lens with a vision defect. And you can see that it converges it beyond the retina right here outside. So now, how can we correct this vision defect? In other words, how can we move this onto the retina? Right now it's beyond the retina. So the question is, can this be corrected by a diverging lens or a converging lens? So let's try, the diverging lens. If I put a diverging lens here, or if the person wears a corrective lens, that's a diverging lens, can this focal point be moved to the retina? Let's watch it. Nope. So it's even moved it further away, somewhere there. So let's try the converging lens. So for the converging lens, if I put that in here, obviously you can see that now the focal point moved to the retina. So let me show you this in the dark room. So this is what you see in a dark room if you put converging lens number 4 as a corrective lens. So if I put it in front of this eye, this defective eye, then you can see that the rays converge exactly on the retina, and this eye would be able to see the object. So a converging lens is used in this case to correct this vision defect.